Hey everyone, just to let you know.
The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, just to let you know, we'll be starting in 2 minutes to allow people to log in. So we'll get started right at 2 minutes after the hour. Well, good afternoon everyone, and thank you for joining. In a minute, we're going to get to Dennis Rigney of Solid, and we're going to talk about public safety and DAS. Just briefly, we're going to go over a couple slides, just a minute or two, and just to give you a feel about Alliance Corporation. Just some of the solutions we provide: microwave backhaul, infrastructure products, anything you see on a tower, supply chain solutions, fiber specialties, connectorization, specialized cables for cellular and wireless, as well as IDAS and ODAS solutions. We have customers all across North and South America, all the way from Argentina to Alaska, dealing with carriers, contractors, integrators, and OEMs. We are a leading distributor of wireless infrastructure products. We have a world-class product assortment, which also includes Solid. We have extensive inventory and facilities across North America and South America. We also provide pre- and post-sales tech support, including training, and we have a very strong team of people to help you out for your solutions. Some of those solutions are cable, fiber, and coax connectorization, antennas, accessories, DAS solutions, indoor and outdoor and small cell, DAS cabling, both passive and active components, as well as antennas. We are the industry experts in PIM, fiber, indoor DAS, outdoor DAS, as well as supply chain solutions. Just some of the things that are driving the indoor DAS builds. InStat numbers show that the hospital and healthcare vertical by itself will reach $4 billion by 2015 in the North American market. What's driving it? Well, one of the things is the narrowbanding mandate for public safety codes, which are adopted by local authorities, as well as capacity offload from the macro network, better enabling the use of spectrum with the new wideband technologies. And an interesting number, 60% of all data sessions are either initiated or terminated indoors. Just a heads up, our next webinar is going to be Advanced Active DAS Design in March 2012. At this point, I'm going to pass it off to Dennis. Dennis has started his career at Nextel Sprint and spent 12 years there and focused heavily on DAS solutions. He's been with Solid for 2 years now, and I'm going to pass it over to you now, Dennis.
Good afternoon, everybody. Thank you for taking a few minutes to attend the presentation today. Again, my name is Dennis Rigney. I'm a Director of Sales at Solid Technologies. And for today's presentation, we're going to talk about public safety, two-way radio, and the impact it's had on all customers, enterprise, and government. So what we're going to review today are changes in the two-way radio networks that have impacted the enterprise. We'll discuss new codes, best practices, and two-way radio in general. We'll provide examples of what customers are facing with regards to commercial two-way radio, pagers, as well as what the public safety is facing, or what provide examples of what needs to happen in order for the public safety to better enhance coverage. And we'll also talk about what it'll take for the enterprise to enable all wireless communications and how that can be achieved. After we're finished today, we'll have a few minutes to do some questions and answers. So if you have any questions during the presentation, please hold those, and we'll get to them at the end. To begin, what we'd like to real quick, we'll talk a little bit about narrowbanding, mandate around narrowbanding. Rebanding, these two things independently impacted two-way radio, paging, as well as commercial cellular. Local public safety building codes, city, county, state safety networks, two-way radios, and paging. We'll provide a couple customer examples, and then as I mentioned, in conclusion, we'll talk about what it will take for an enterprise or anyone to enable all wireless communications in an effective manner. To begin, we'll start with FCC narrowbanding mandate. The FCC established an initiative in 1992 that all equipment manufactured since 1997 would have to be 2.5 compliant. In 2004, the mandate was implemented with a deadline of January 1st, 2013. So essentially all equipment sold after January 1st, 2013 must be 6.5 compliant. The objectives of this were to increase capacity and efficiencies as well as generate revenue. All businesses, educational, industrial, public safety, local, state, anyone two-way radio license currently operating legacy wideband radio systems need to make the transition from 25 to 12.5 by the state. Who's involved in implementing? There's OEMs involved, such as Motorola and Kenwood, as well as dealers or integrators like local two-way radio shops all throughout the country. What does it mean to the average person or the average enterprise? New VHF, UHF radio systems will be deployed, and some will require DAS. Existing systems may be tuned to maximize new efficiencies, which again could, which would require DAS improvement or potential DAS improvement throughout facilities. That's narrowbanding. And then rebanding, which is essentially 800 megahertz band reconfiguration, was planned and adopted by the FCC July 2004. Originally, it was a 36-month. Originally, it was planned to be a 36-month period, but it's way behind schedule. Who's involved in implementing this rebanding initiative? 800 megahertz transition administrator, which was directed by the FCC, Sprint Nextel, and Sprint Nextel is actually funding most of the rebanding initiative. What does it mean to us? All parties will be able to better utilize, fully utilize 800 megahertz spectrum for in a cleaner fashion. Essentially, what they're doing with the 800 megahertz rebanding, rebanding effort is eliminating interference in the 800 space, so that commercial wireless and SMR, such as Nextel or private two-way radio networks, will be in certain bands, and the public safety will have a contiguous band or contiguous spectrum, and it'll eliminate any opportunity for interference between those two bands, between those competing two-way radio systems. Next, pretty hot topic right now throughout the United States, at least, we're hearing more and more about public safety codes, public safety initiatives, or public safety best practices. In some cases where there is not a code yet on the books, at least being prepared or public safety ready. More and more enterprises, more and more customers are talking about this. More and more public safety officials are starting to spread the word that they want people to be public safety ready. And to that end, we wanted to talk a little bit about what public safety is and some of the codes that are there and how they're impacting enterprise. So first of all, some of the National Fire Protection Association, they've developed codes and standards to minimize fire risk. The International Code Council, ICC, or the IFC, adopted by local cities, counties, states. They have authority having jurisdiction, or AHJ. Basically, they set best practices, guidelines, and laws for indoor enhancement of public safety two-way radio systems, such as 150 VHF, 450 UHF, or 700 or 800 megahertz two-way radio systems. There are some places where an ordinance may be required before a certificate of occupancy is released in new construction. There also may be a best practice where it could potentially reduce building insurance rates. If you have, in some cases, if you have public safety ready, or if you have a public safety system, you actually can apply to your insurance company, so we've heard, and receive a reduction in your insurance rate. These are things that potentially could help or hinder the enterprise as they're moving into new space, or if you're a landlord or a tenant's coming in and you're not public safety ready, it could hinder the progress of that as well. So even where there's not a code, as I mentioned a few minutes ago, a best practice, there's a lot of talk around best practices. Well, if I can be public safety ready while I'm solving a commercial cellular problem, that's in my best interest. How do I do that? So there's this constant request for information around what can I do to become public safety ready? How can I help improve the communication in my building in the event of an emergency? Or just how can I help improve the communication in my building with all of these different frequencies, with rebanding, with having no more 800 spectrum available here, but VHF is the replacement, or UHF is the replacement. All this communication around disparate networks and how best to manage those. Separate systems for public safety and commercial services present an opportunity for interference, so making sure that when you put systems in, you're putting them in cleanly. There's no interference. There's no opportunity for interference. All the systems can work in parallel with each other. And that's really important, because the last thing you want, obviously, is to put a public safety system in and have someone come in with a commercial, say, radio system, cause interference, and then if you need the public safety system, it's not going to work up to par with what was expected. So those are real important points that you need to focus on, or everyone needs to focus on when making a decision around how best to address public safety within their enterprise. Who's involved in implementing some of these codes and practices? Public safety officials, the fire department, police department, your local two-way radio dealers, and some experienced DAS integrators. From a city or a county, state public safety network perspective, many of the states or government departments are implementing two-way radio networks. Some of those now include 700 megahertz spectrum or 700 megahertz radio systems for public safety as well. So they're, again, a wide range of networks that are available for them to operate on, and something that's extremely important to note when you're talking to an enterprise about providing coverage. It's important not to assume that it's just a digital system or it's just 800. Really understanding, what does the local fire department have? What does the police department have? Are they different? Can they both work on one network? What else can work on that network? Can I get my 900 pagers on there? Those types of questions are really important in understanding a complete, what is the best complete solution for your customer that includes any and all disparate networks that they may need within their facility. Most existing networks have tall towers that transmit high power and effectively penetrate most buildings. well, most buildings are on an acceptable voice level, so they can push a button and communicate over voice. Some of the new 700 broadband networks will provide data as well. When you introduce data into the network, it may become more like a cellular network, which will require smaller, more dense nodes or antennas. Therefore, the opportunity to introduce DAS to support 700 megahertz data, public safety data, may be a requirement in some of these locations that currently have two-way radio systems, say in the 800 band or whatever, that are working well. And if they introduce 700 as a replacement or to augment that, and data is included, you may need to relook at the propagation of that system and whether or not it will be sufficient to support data as well as voice. Building penetration will be limited, and DAS will be required to deliver seamless data experience. And who's involved in implementing that? Again, the radio OEMs, Motorola, Harris, Raytheon. Again, probably those core group of integrators throughout the country, and then others. Could be cable pullers, it could be manufacturers, could be a number of people on the DAS side as well. Two-way radio and paging. Various business and public agencies utilize two-way radios and pagers as a primary or supplement, or they supplement an existing network, such as utilities, healthcare, hospitality, or transportation. Some of the networks that they may use are, VHF, which starts in the 150 range, all the way up through 900 megahertz SMR paging. In a down economy, radios and pagers are already paid for. They provide a non-capital expense. They've already been paid for, so they're being amortized out over a number of years. There's no recurring OPEX to manage them. So in a down economy, these radios are being used for a longer time. It's perceived, potentially it's accurate, that it's much cheaper to maintain a network than it is to replace it. Paging networks are being downsized, leading to coverage gaps that didn't exist in the past. Again, this offers an opportunity for the expansion of DAS, or the introduction of a DAS that includes more than just paging, but can plug the gaps that have been created by these networks being downsized. Sprint's integration of Nextel led to about 15 million subs moving away from Nextel. Some probably moved to true commercial cell phones. Others may have moved to other types of push-to-talk communications. Not certain where every single one of them, where they all went. However, it's for certain that they're moving away from the Nextel push-to-talk and onto other networks. Often overlooked are the IT departments involved in looking at DAS. Typically, the IT department was not responsible for managing radios or pagers. Those were handled by a telecom group or a radio specialist or somebody else within an organization that probably does not have involvement in IT-like functions such as commercial cell or Blackberries or smartphones or anything other than two-way radios or pagers, kind of the original technology. So a great way to add incremental value to a commercial DAS is to talk about all these points to the correct people, to the multiple groups of people within an organization, and provide an overview that can solve for everyone's problem over a single system. So by consolidating networks into one DAS that can support wideband all of these technologies, you're enabling each of these groups, whether it be a paging group, whether it be a radio group that may need some additional penetration, or whether it's the commercial data and cell phone providers that people are using more and more. Having conversations across an entire enterprise about all of these opportunities can provide for a single solution, which typically enterprises are looking for. It reduces cost, reduces the amount of space taken up, and it provides a fix-all solution to everything wireless within their organization. By example, selected a healthcare customer, an example in the West, and this is a major healthcare network, and their breakdown of what their devices look like, just to give you an example of how many devices or how many different networks one customer may be operating, but more importantly, by the numbers, how important these networks are. Each one of these networks are how important they are to the enterprise. So this specific customer had about 60,000 CL commercial liable cell phone devices. They had 60,000 commercial/long distance pagers, 15,000 local company-owned pagers for telemetry, and 10,000 UHF radios for facilities, clinicians, and security. So 4 networks approximately right there, plus, you know, and that's just for your voice and, you know, for your voice and paging needs. That's not Wi-Fi or anything else for higher speed data. So in addition to that, they had, so a standard DAS configuration for this customer would look something like UHF, which is 450, 700 LTE, 800 public safety, 900 paging, 800, 900 for Sprint, 850 Verizon AT&T, or 1900 for AT&T for all the carriers, and then 2100 for all the carriers plus the new carriers coming on as well. So you can see here that you'd literally cover everything from 450 all the way up to 2100. That's what this customer has a need for. Wide band of spectrum, all have a very different need, all have very different purpose, and the opportunity here is to solve for all of those bands. Another example, hospitality customer. This example is 15 casino resorts in Las Vegas. This group of casino resorts had 800 CL cell devices, 2,500 individual liable cell devices, which leads to a second issue is when they're individually liable, the enterprise cannot control what network, what carrier they are. So not only do you have to solve for do not have to solve for commercial cell, you have to solve for every different opportunity in that commercial cell spectrum. So all carriers, all frequencies, etc. 5,000 commercial 900 megahertz pagers, 1,300 800 megahertz radios, digital radios for housekeeping, security, facilities. So in this example, this standard DAS starts a little bit higher. I'm going to start at 700 LTE, 700 public safety, 800 public safety, 900 paging, and then 800, 900 Sprint, 850, 1900, 2100. So again, going from 700 all the way up to 2100. Now, a few things I'd like to point out on these. Not only is the band, or I'm sorry, the spectrum of frequencies wide, so 450 on the previous one up to 2100, or 700 on this one up to 2100. But you'll notice also that there are different protocols or different applications in the same band. So as an example, 700 LTE and 700 public safety, or 800 public safety and 800 IDEN, 900 paging, 900 Sprint. There are different applications in the same band. So not only do you have to solve for something that can support wideband, you have to solve for something that can support multiple protocols in each of those bands, such as public safety and LTE in the 700 band, or 800 public safety and 800 Sprint in the 800 band. So there's very much the consideration needs to be, can I provide one network to support all of these, and will that one network eliminate any opportunity for interference so that everything works properly once it's installed? And then, of course, you have the consideration of I'm putting multiple carriers sharing the exact same band for a pretty similar reason, such as 1900 or 850 as an example, where you have multiple carriers coming in. So now you need to consider also solving for the carrier bands and multiple carriers as well. So how can you address public safety on the DAS? Well, before you just address public safety, I think what we've covered today so far is kind of where two-way radio started, how it's changed a little bit, how some of the frequencies have been rebanded, how they've been narrow-banded. I've showed examples of where public safety is, where it overlaps with some of the commercial cell technologies in the same band, and then also how it's important to consider the fact that the bands are wide. 450 all the way up to 2100 is really what you have to solve for, as well as the commercial the commercial carriers. So when you talk about solving for these things, the first few things that you need to do, going back to those codes that we talked about early on, is select products that can support. You'll notice here it's NFPA, IFC. Those are some of the codes that we referenced on the first page. You need to make sure that the product is public safety ready day one. The reason for when there's not a code on the book, or if there is a code on the book, if there's a code on the book, it's pretty easy to understand what needs to be done. If there's not a code on the book and you want to become public safety ready as a best practice, what you need to understand is, who writes the codes, which we talked about before, and how they want the codes met. Well, part of that is selecting gear that is within those codes. So NEMA 4 compliant or NFPA certified, IFC certified, those types of codes. These are a few that you would need to look for as certified, as the DAS being certified to meet. In addition to that, we talked earlier, you need to select a DAS that can start at the very low range, so 150 VHF, and go all the way up through 2100 on a single infrastructure. Some people will install parallel systems, so they'll have one system for commercial cell phones and a second system for two-way radio. That provides parallel systems, so two systems to manage, two systems to install, two systems to maintain separately, as well as separate antenna points, separate. It's literally a complete parallel system. What you can look for today is a single system that provides coverage for all carriers, all two-way radios, all frequencies over a single system, consolidating not only the amount of space, not only the systems, the physical systems into one, but also the amount of space that is required to install these systems throughout the facility. And again, not just selecting someone that can do that, but selecting someone that can do that, but still affords the fire code or readiness and meets all those NFPA or NEMA 4 fire codes. So, consolidating all those bands into one system and making sure that the system is as efficient as possible. So minimize the number of active components, minimize the number of passive components, minimize the amount of fiber that is required, which allows for the customer to focus on other requirements for that fiber. That's also important. So get as much of the coverage, as many of the frequencies covered as you need, with using the least amount of equipment, and that saves space, it saves money, it's an efficient way to meet everyone's needs. The other thing is you want to find a track record of success. For an example, just as an example, find some customers that have done this, that have gone wideband from 150 all the way through the 1900 or the 2100 channel, and make sure it works. Make sure that it doesn't, there's no interference. Make sure that a single system works as well, actually works better than a parallel system for the customer's needs. And that's an important part when you're selecting a part. And then last, and I mentioned this briefly before, public safety has a very important need within a building. Hopefully, the need doesn't arise for most of us, but when it does, that system needs to work. Being able to manage and maintain that system as efficiently and as effectively as the commercial carriers manage their cellular networks is equally as important as selecting the right system. When you select an active passive DAS, for an example, that has monitoring and heartbeats, you can see the system, you can make sure that it's operational before it's ever, in downtimes, as well as, when you want to test it. rather than, rely on testing it periodically to make sure that it's working, you could get full management and full monitoring of the system real time, 24/7, and make sure that not only your commercial cell system is working, but also your two-way radio system is working. Often cell providers absolutely mandate that they have certain visibility into their commercial cell systems, that they have certain monitoring, that they have reporting on how their DAS is working within buildings. Well, that's just for commercial cell, for you and I and for everyone else to make a phone call or do some data transmission. Why wouldn't the same criteria be important to the public safety two-way radio? It should be. And providing a single system that can be monitored and maintained through a NOC or 24/7, 365 is as important on public safety as it is to the commercial cell carriers. So again, making sure that your system can be managed and can be maintained, as well as support all of the carriers, all of the bands. Those are the most important decisions to be made when selecting a partner. So Mike, at this point, that concludes my overview of public safety as it relates to commercial and the changes that have gone on in the industry. And I'm happy to turn it back over to you.
Thank you very much, Dennis. Appreciate that. All right.
Dennis, we just have a few questions. I'm going to assign them to you.
Okay.
So if anybody has additional questions, please type them into the chat bar. We'll get at them as soon as they come in.
Dennis, you should see some questions. I just assigned them to you.
Yeah, I just want to, they're not, hold on one second.
Well, I'll just read them out.
No, I can see them.
Oh, okay.
So with regards to 800 megahertz system, the 800 megahertz, the DAS can provide, or the DAS can expand the coverage of an 800 megahertz system throughout a building. So whatever 800 megahertz public safety system or two-way radio system is plugged into the head end of the DAS or the base interface unit of the DAS can be distributed through the fiber coax system or active passive system throughout the building. So typically, you may see repeater-like solutions for some two-way radio systems, and this wouldn't be necessarily to replace them. This would be to expand them into areas that they may not have coverage. So to answer the question, any 800 megahertz two-way radio system can be expanded using the DAS. This is the 800 frequencies are not limited in this solution. Can a little more detail on SAW filter capability be described? Sure. At a high level, surface acoustic wave filtering is just it's a military-grade filtering that Solid Technologies chose to implement in their product. And basically what surface acoustic wave filtering does, in short, is it really tightens up the skirts, the roll-offs on each of the individual bands. And what it allows us to do is, what it allows Solid to do is it allows them to transmit things like 700 public safety and 700 LTE over the same DAS without any interference. And because of the filtering, because of the tight skirts on each of the bands, it allows the data traffic to go through to be transmitted without any additional filtering, because they would filter the public safety greater using SAW filtering. So the data traffic in 700 LTE will not be interfered with, and it will also not reduce, there will be no additional latencies. So at a high level, surface acoustic wave filtering is in addition to cavity filtering. It's an additional layer of filtering that really just cleans up the frequencies and allows, all of the different two-way radio and commercial cell providers to operate in the same band without any interference. Yeah, By the way, that's a software filtering. Soft filtering is a software filtering. Do you have any plan to bring 2.6 band to the BIU or ROU module? At this point, 2.6 is pretty much exclusive to Sprint. We have, as Solid, talked about developing a card, began developing a 2.6 card some time ago. The focus of WiMAX has been not over DAS. It's been primarily over APs, and therefore Solid doesn't currently have the 2.6 card. However, if there's a need or an interest or some requirement for 2.6, I know in Canada it's been a big conversation piece, and my engineers and I have taken that back to the R&D people and found out what the next steps are regarding that. So I think more to come on that is the best way I could answer. Sorry, I'm reading these on a very small line here. What level of signal conditioning is required at the BTS and the BIU? We have software conditioning when, so basically our input level would need to be between -20 and +10, and then once it comes into the BIU, it's software attenuated to where the system needs it. As far as it comes in, as far as additional conditioning, most of the time what we see is on Solid system, it's a simplex input, so it comes through like a circulator into the system at, again, -20 to +10, and then it's software attenuated to where the system wants it. Okay, so how do we deal with MIMO for LTE and HSPA? Okay, so we'll take these two separate ways. So for depending on the system, MIMO can be handled over a single strand of fiber, over a single remote, over a single head end. So a single BIU, single strand of fiber, single remote cabinet, and then out of that cabinet you'll have two passive legs. So that would be for 700 LTE. For other bands that you wanted, and this not just HSPA, this could be any band that you wanted to do MIMO in, you would need to essentially double up the actives and the passive component. So you would need to create a parallel. You would need to use two strands of fiber. You would need to create a second leg for 2100, and then on the active side, a second remote, and then also a second passive run out of that remote. So for anything other than 700 LTE, you would need to put in a second set of active components currently. Okay, I have a question here on PIM specs around public safety, and while I've done some work with the engineers on PIM in general, I am not certain on this specific question with regards to public safety, so I'm going to take this one and have one of our engineers reply. If whoever submitted that question could kindly just email Lisa, I will make sure you get your detailed answer. I'm just not familiar enough with the public safety portion of that question to answer. Typical spacing of the indoor DAS antennas, that's a difficult question. It really depends on the building. If it's a concrete building or if it's a sheetrock walls, I mean that question could go, could really go, in very different directions. What I can say is we typically see anywhere between 6 or 16 antennas off of a single remote, and depending on the makeup of the building, I've seen the DAS cover a single remote cover as much as 80,000 square feet or as little as 50,000 square feet. So unfortunately, there's not a rule there that I could simply state a distance. However, generally speaking, it's between 6 and say 16 antennas, and about 50,000 square feet in a real dense building, up to 75, 80,000 square feet in a more open area. What is a good source of material to start learning about public safety? That's interesting because when I was putting this together, I was actually scrambling to try to find out some new facts, and I think the best source is really, I mean, in my opinion, actually, I borrowed some of this from, most of this from a coworker, but I believe like a lot of the industry rags and different types of publications on public safety standards and the FCC website, et cetera, I think it's really just, you know, research, trying to find something that works for one thing, one topic, and then, you know, expanding into others. As I mentioned, you know, most of this presentation my coworker put together, and, you know, I believe he kind of pulled from probably 5 different sources to get this information. So I don't think there's one great source. I think there's many good sources, and you know, they start with the FCC website and then local codes, and there are some people who speak on public safety, you know, throughout the country, and I believe that Solid is going to take an active role in, you know, publishing some papers on public safety with some partners, and doing some more educational stuff on public safety as it relates to DAS. So hopefully the answer to that question will be Solid in the near future as we continue to, we're finishing up some papers on public safety and some other information, and we'll be looking to get those out as soon as possible.
I got a couple of questions that I can take right now, Dennis. Question is, are we going to see these mandates take effect in Canada also? I haven't heard specifically when these will take effect, but I do believe that they are coming, you know, sooner than later. You know, Canada always seems to be a few years behind what the U.S. does, and seems to follow suit, though, on that. And then the next question, does Alliance manufacture the components for the systems? No, Alliance doesn't, but Solid does. Solid is the actual manufacturer of the system, and we're the value-added distributor for it. So we also can provide engineering support as well. So those are the 2 questions I had. Back to you, Dennis.
Mike, there's a lot of questions on here that are kind of specific to bands and frequencies around Solid. You know, I think what I would best do is, you know, I can field all these questions if they've been emailed to Lisa, or if you could email Lisa, I'm happy to email them. What I can say on the remaining questions is this deck will be available to be downloaded. I believe Lisa is going to make it available to everybody. If there are any questions on the deck, my information is available. You can please feel free to email me, call me, or you know, reach out through Lisa to me if for some reason you can't find my contact information. And I'm happy to answer all these questions about the you know, Solid system specifically, and the frequencies that we handle.
It's Lisa here. I think what I'm going to do, because there are a lot of questions, and I'm fortunately the system does record them for me, so I will follow up with everyone who asked a question with you, Dennis, so that they can get an answer from you directly. Is that okay?
That's perfect, yeah.
Okay, great. So you don't need to email questions unless you have any that you didn't ask during the webinar. And I'm going to be emailing the deck, the presentations, as soon as I can. It'll definitely go out tomorrow at the latest, but hopefully today. And I have recorded this webinar, so I should be able to send out a link to where you can download the recording as well if you'd like to watch it again.
Well, thank you very much, everyone, for joining, and thank you, Dennis, for presenting. Really informative, and we appreciate it. And once again, thanks, and look forward to our next webinar.
Thanks. Thanks again, Dennis and Mike.
Thank you.